What is the most influential scientific paper of all time? Seriously, think about it. Is it Einstein on relativity? Maybe Watson and Crick on DNA? You'd think it would have to be some famous, world-changing discovery, right? But the real answer, well, it reveals something deep and honestly kind of surprising about how science really works. And it all starts with one single, massive number.
13,186. That's how many times a single scientific paper has been cited by other scientists. And get this isn't even for a massive field like physics or biology. This is the top-ranked paper in nephrology, the study of kidneys. Just to put that in perspective, if your paper gets a few hundred citations, you're a rock star in your field. This number, it's just legendary.
So what do you think it is? What kind of paper gets over 13,000 shout-outs from other researchers? Has to be a groundbreaking cure, right? Or some revolutionary theory that rewrote everything we know about the human body. Well, whatever you're picturing in your head, it's probably not this. Because the answer to this mystery forces us to challenge our most basic assumptions about what makes a scientific paper truly important. You know, when we think of great science, our minds immediately jump to those huge Nobel Prize-winning moments of genius, the kind of stuff we all learned about in high school. These are the discoveries that become the bedrock of how we understand the universe.
But here's where it gets interesting. There's this fascinating split. On one hand, you have the famous discoveries. They become so fundamental, they just turn into textbook knowledge. I mean, you don't cite Isaac Newton every time you talk about gravity, right? But then you have this other group, the citation superstars. Their fate isn't to be a fact in a book. Their fate is to become an essential tool that scientists use and cite every single day.
Okay, take Sir David Cox's paper from 1972. He didn't discover a new disease or anything like that. No, he created a statistical tool, a model, to analyze survival rates. So, for example, researchers can use his model to figure out if a new cancer drug actually helps patients live longer than an old one. This tool is so incredibly useful, it's been cited over 42,000 times. It is a true workhorse of modern research.
And that's the big secret. The bestsellers of the scientific world, the papers with these just astronomical citation counts, they're not about discoveries, they are all about methods.
So what exactly is a methods paper? Well, think of it like this. It's not about the what, it's about the how. It's a recipe. It's a how-to guide. It gives other scientists a brand new technique, or a new equation, maybe a new piece of software, or even just a set of guidelines that makes their own research possible or at least a whole lot easier. It's like a gift to the entire scientific community.
And if we go back and look at that top 100 list in kidney research, the pattern is it's crystal clear. The fourth most cited paper, a new equation. The 13th, practice guidelines. The 39th, a rapid and precise method. See? They're all tools. They're all methods papers.
But it gets even more interesting. It turns out how useful something isn't the whole story. Citing a paper is also a social practice. It's a cultural norm within different scientific fields. And this is perfectly illustrated by a little tale of two fields.
Let's stage a showdown between two hugely important areas in chemistry. In one corner, we have density functional theory, or DFT. You can think of it as a really powerful computer simulation that predicts how molecules are going to behave. And in the other corner, we have nuclear magnetic resonance, NMR, which is a physical machine. It's like an MRI for molecules that tells you their exact structure. Both are absolutely essential, but their citation habits, worlds apart.
Okay, so in the world of DFT, there's a really strong culture of citing your sources. When researchers use this method, they don't just cite the specific software they're using, they also cite the foundational theory papers from way back in the 1960s that the whole field is built on. It's just what you do.
Now compare that to NMR. NMR spectroscopy is used by chemists every single day. It's probably even more common than DFT. But the original, foundational papers are almost never cited anymore. So why not? Because the technique has become so routine, so fundamental, that it's just considered basic knowledge. You don't need to cite it, any more than you'd cite the person who invented the glass beaker.
A researcher named Mark Roussel summed it up perfectly. He wrote, "When experiments become sufficiently common, chemists stop citing their original sources." So get this, a low citation count doesn't always mean low impact. In some cases, it can mean the exact opposite, that something is so important it's just assumed.
So all of this means we really have to redefine what we mean by impact in science. Clearly, it's not as simple as just counting up the citations. What we're really seeing here is that true, lasting scientific impact isn't always that single, eureka, lightning bolt moment. More often than not, it's the quiet, steady work of creating a reliable tool, a workhorse, that empowers an entire generation of scientists to make their own discoveries.
This classic XKCD comic just illustrates the point perfectly. Experts get so deep into their own fields, they completely forget what isn't common knowledge to everyone else. And maybe that's the ultimate sign of impact, when your tool or your idea becomes so fundamental, so second nature, that people forget it even had to be invented in the first place.
And that leaves us with a final, big question to think about. If citation counts are really just a reflection of a field's cultural habits, then how should we measure scientific influence? What does it truly mean for an idea to change the world? It seems the answer is a lot more complicated than just counting to 13,000.